Welcome back. Hello everybody. In this video we are going to learn how to calculate water quality index using Python. And you don't have to be worried about Python because you don't need to be a good programmer to calculate this index, and you can do some other basic statistical analysis without having any prior coding experience. So to do that, at first you have to install Python. So we are going to use Anaconda. At first move on to anaconda.com, then under these products go to individual edition, then scroll down, and here if you are a Windows user or Mac, depending upon your download it. I am going to download this one and then install it. After installing it in your local computer, you just need to search it from here. Just write Jupyter notebook, click here, this window will pop up. Now fine, this is called Jupyter dashboard. So from here you can go to any folder and start your Python programming. So we are going to OneDrive, then desktop, and I have created a folder called data science files. Here we are going to create our first programming work. Now go to here, new, then Python 3, and now in front of you a Jupyter notebook is open. We will do our calculation here. Now we print PRI, print hello guys. So to execute this cell, just hit Shift plus Enter. Okay. Now to read our data, you need to use pandas library. So we are going to import it. Import pandas as PD. Fine. Or you can run this cell from this section, run. Okay. Then now we are going to call our data. So to read your data in Python, what you need to do is you have to place your data in the folder where you have started this Jupyter notebook. So this is my data, water quality. I have stored this data in the folder where I have initiated, or I am running my Python code. So do that at first. Well, after that, now we are going to load our data. To load our data, you have to write pd.read Excel. This is an Excel file, that's why I am writing Excel. Bracket, comma, quotation. Write the Excel file name. So my Excel file name is water quality, so I'm going to write here water quality. then specify the extension. It is xlsx file, and I'm going to give a name to my data, so call it data frame df. Data successfully loaded. Now inspect our data. Df dot head fine. So now see our data contains latitude, longitude, union, well depth, bicarbonate, calcium concentration. Here I have got 13 water quality parameters. So before moving forward, let's see some basic statistics. Now so let's write df dot shape. Now see, we have 64 rows and 17 columns here in this data frame. That means you have 64 data points and these 17 rows features. You can also see df dot describe. Count 64, total mean, standard deviation, like mean calcium concentration is 103 milligram per liter. Here 25 percentile, 50 percentile, 75 percentile, maximum value. This tool is really handy. Okay, let's say you want to know how many stations have exceeded arsenic concentration 50 milligram per liter. Here 50 microgram per liter. Here arsenic concentration is in microgram. So how do you calculate it? In Excel I don't know how you do that. Maybe you count one by one. But in Python you can do it very easily. Just write your data frame name df, then specify the column you want to inspect, arsenic, then I want it more than 50, so I'm going to store it in a variable like how many. So run it. Okay, see, these are the data points which have exceeded arsenic 50 microgram per liter. Now you can inspect the length by just a length of how many, 15. Out of 64 samples, 15 samples have exceeded drinking water limit. Now you can also see from which union we have collected how many samples, or from which location or union how many maximum number of samples are collected. To do that, just write this code df.group by union. We are going to see that by union, that's why group by union, and count it. Let's say bicarbonate for, see, now you 13 from this location we collected maximum number of samples. Now you can also plot it. So right here just dot reality plot. Oops, it's a line plot. I want kind bar plot. You can increase the figure size. 10/7. See, this union Kaiju contains maximum number of samples. Okay, now go to water quality index, and in this tutorial we will be using this equation to calculate water quality index. Here Ci is concentration and Si, S means standard value of that chemical parameter, W it's called weight, and W will be divided by summation of weight. So how you can find these weight standard limits? Weights you can find weight from literature, standard also. So here my standard limits and weights, and you have to sum them up, and this in my case it is 49. The summation of all of these weights is 49. Okay, so in this equation summation of Wi is 49 for my case. Now in Python you have to write that equation. So to write a function in Python, it's pretty easy actually. At first you have to define a function, def. Def, give it a name, any name as you want. Let's say example, then in bracket, for example I want x and y parameter. After that give a colon, enter. Make sure to have this indentation, 4 lines of indentation. Then write your formula, maybe z is equal to x plus y, then return that z. Okay, your function is ready. Once you have written your function, now you have to call your function. So write the name of the function, exmp, then provide the values of x and y. Let's say x is 2, y is 3. See, this is our output 5. This function executed this formula x plus y. So x is 2, y is 3, output is 5. Now let's say we want to multiply this summation by 2. So sum it, multiply it by 2. Now it's 10. So this way, similarly we will write this equation. To do that, replace x by, say for example, concentration, then it's our weight, and S for standard value. Then here we will calculate relative weight. Relative weight is equal to W weight divided by summation of all weights. So in my case it's 49, but in your case it might not be same. Okay, after that here see, this is relative weight. After that we will calculate this one. So to do that, let's say water quality index is equal to relative weight multiplied by concentration, then divide it by standard. then again multiplied by 100. So now we will return what? Return water quality index. So we have written this one, and here SI is sub index, and we will see that in the later part of this video. And final outcome is summation of all SI. SI means sub index, index for one parameter, for example for calcium or bicarbonate, etc. Okay, our formula is ready. Now call the function concentration. How we have 64 concentrations for bicarbonate, 64 concentrations for calcium. How do we call them? 64 concentrations at a time. So to do that, let's say df dot calcium. You see, you have here all the concentrations for calcium. Similarly, if you type here HCO3, you will have all concentrations for bicarbonate. So now what we will do, we will replace the concentration by df dot bicarbonate. Then wait. From this table you have to identify what is the weight for bicarbonate. In this case it's 1, so give it 1. And what is the standard limit for bicarbonate? It's 500. So 500. Let's execute it. See, all the sub-index values for bicarbonate is here now. Now we want to store our result in a variable called x. Now let's inspect our data frame df. This is our data frame. Again, we don't need this latitude, longitude, union, well depth, etc. So let's drop them df. Okay, let's inspect our data frame. See, there is no latitude, longitude, union, and well depth. Fine. Now after we calculated sub-index value for bicarbonate, we want to make a new column for bicarbonate sub-index. Here we want to see another column. So to do that, you can do that easily. Just write here df, specify here new column name. I'm just going to give that sub index HCO3 is equal to x. That's why I have stored my data in result in x. So okay, again see here sub-index column, a new column for bicarbonate sub-index. Similarly, we'll repeat it for all of our chemical parameters. And now here you have to change bicarbonate to calcium and change the weight. For calcium it's 4 and standard value is 75. Again right here calcium, give it. Let's see our data frame. You see now one other index is added for calcium. So I'm not going to do that for all of the chemical parameters. I'm just going to show you for these two sub-index how to calculate final index. And now our task is to add sum these two sub-index. So how can I do that? So to do that, let's df.ilog. We are going to keep all the rows, but now we just need these two columns. So it is 14 column and it is 15 column, so we don't need this 13 column. So okay, we need columns from 13, that's why. So semicolon 13 to the last one. Okay, fine. Store it in a variable called z. Let's see z. See, z only contains these two columns. Now our task is to sum these two columns. So to do that, write z dot sum and x is equal to 1. Why x is equal to 1? Because by default it will sum them vertically, but we want to sum them in horizontally. That's why you have to specify axis is equal to 1. So store the summation in another variable like c. Let's see c. That's it. So we're going to add this c to the z. Final index is equal to c. Now again, what is it? See, now your z contains all the sub-index values and also final index. So now I want this data frame as an Excel sheet. So to have that, write z dot to underscore Excel and write name water quality index dot xlsx. Then run it. Yes, it's successfully loaded. Now go to the folder. Let's see water quality index. That's it. That's it. Now here is our final index. Now if you want to do more things with Python, like you want to see data distribution, is it skewed or not, or your data is normally distributed or not, and you want to see this correlation or different visualization like this, then you can check out my another video on YouTube. I will leave the link in the description box below. So now I think you have learned something new, or you find this video helpful. If you find this video helpful, please subscribe and like. I hope I'll see you in another video.